Okay, so here we have our rules for integration. If k is a constant, then we have kx, and like I said before, really what we're doing here, we're finding area under a curve. So if this is our k, and we want the area from, let's say, 0 to x, we're just getting the area of a rectangle. And that rectangle has a base of x and a height of k, so it's k times x. There's our area.
Hi, Daniel.
Okay? Now, the next rule, the power rule,
What about the C?
okay? For the power rule, we always have a plus c. We always have a plus c. Notice here for the derivative, there's a stipulation here, and that is, as long as n is not equal -1, okay? Now, you'll see why here in a second, but notice if we were taking the derivative of x to a power of n plus 1 over n plus 1, and n was some constant, you guys know the power rule, you would multiply by the n plus 1, and then subtract 1 from the exponent. So now it's n plus 1 times x to the n. And because this whole thing we can treat as a unit here, we would cancel those out, and it's just x to the n. Okay? Well, here we can see the integral of x to the n. We add 1 to the exponent, and then divide by the new exponent. Okay? Don't divide by the original exponent, divide by the new exponent. So you add 1 to the exponent and divide by the new exponent. And why would this only work when, as long as n does not equal -1?
Because the denominator would be 0.
The denominator would be 0, yeah. -1 plus 1, we'd be dividing by 0. So we actually have a different rule for if we have x to the -1 power. And you can see that actually right down here. We'll skip e to the x for a second. But notice here we have the integral of 1 over x. And this one is directly from one of our derivative rules. The derivative of ln of x is 1 over x. Okay?
I think someone asked this question before in class.
Yeah?
If it's 1 over x, why should it just be ln?
Yeah. So the integral of 1 over x dx is ln of absolute value of x. That's the only part that's added here with the integral. And that's because, remember, the natural log has a range, or sorry, a domain of only the positive real numbers. Okay? You can't take ln of 0, you can't take ln of a negative number. So that's why it's ln of absolute value of x.
What if it's like 3x to the -1?
3x to the -1?
Then
You would, well that, okay, if you have a constant times x to the -1, the integral rules work the same as the derivatives. Like when you had the derivative of 3x squared, the derivative of x squared was 2x, and then you multiplied it by the 3. If we have the integral of a 3x to the -1, you just say, okay, well the integral of x to the -1 is ln of x, so it's 3 ln of x. You just multiply it after you take the integral. Okay? Alright, taking a step back here, you guys remember the derivative of e to the x was e to the x. Well, guess what the integral of e to the x is? E to the x, okay? Plus c. So then, our next rule here, the integral of cosine is sine. Notice the signs here, positives and negatives. The integral of cosine is positive sine. The integral of sine is negative cosine. And here's what I showed you before. Remember, you can look at it like this. Sine, cosine, negative cosine. As you go down, it's derivative. As you go up, it's an integral. Or, remember I showed you kind of the wheel. If you write it out kind of like the unit circle has positive cosine, positive sine, negative sine. The x and y coordinates are the cosines and sines.
Wait, I don't get that.
Okay, if we rotate around clockwise, that was taking the derivative. So the derivative of sine It's terrible. That's taking the derivative. The derivative of sine is cosine. The derivative of cosine is negative sine. Derivative of negative sine is negative cosine. Derivative of negative cosine is sine. However, if we go backwards, that's doing the integral. Okay? So if we go backwards, counterclockwise, we're doing the integral with respect to x. So the integral of cosine is sine. The integral of sine is negative cosine. The integral of negative cosine is negative sine. And the integral of negative sine is positive cosine. Okay? So that's a little way to help you remember that. Going around clockwise is the derivative. Counterclockwise would be the integral. Okay?
So sine, cosine, negative cosine, negative.
Yep.
Wait.
So let's work through a few examples here using these rules, okay? So I want to integrate with respect to x. The other thing I want you guys to get used to doing is using proper notation, okay? So I'm taking the integral of 2 sine x minus cosine x dx. Now, just like with derivatives, if you have multiple functions that you're taking the derivative of all at once, you can just handle them one at a time as long as they're being added or subtracted. Okay? So, I don't have to write it out this way, but I can think about this way. 2 times the integral of sine of x dx minus the integral of cosine x dx. Okay? Now again, you may not write that out that way, but that's at least how you can think of it to figure it out. Okay? So, what's the integral of sine? Negative cosine. So here we have negative 2 cosine x.
Plus c.
Okay? Minus integral of cosine is sine x. And then you only need to put the plus c once at the end. Okay? It's fine if you put it on the first, it doesn't matter where it is, you just have to have a plus c somewhere. Okay?
In the final answer, right?
In the final answer, yeah. Don't ever put two plus c's in there, because a random constant plus a random constant's just going to be a random constant. So you just need to put it in once. Okay? So, how about, let's look at part B here. We have a negative 2 over x. So again, the way you can think of this, even if you don't write it down, okay, we're doing the integral of negative 2 over x plus 3e to the x dx. We can think of this as negative 2 times the integral of 1 over x dx plus 3 times the integral of e to the x dx. Okay? Well, what's the integral of 1 over x?
ln absolute value of x.
Yeah, there you go. So now it's negative 2 times ln of absolute value of x. Okay? Plus 3 times e to the x. The integral of e to the x is e to the x. And now you have a plus c.
Boom.
Okay?
But you never have to add an x.
Hang on. What?
You never have to add an x to the derivative. So the
No,
derivative
because
of
it's
3
3
is
times. If this were 3 plus e to the x, then it would be a 3x plus e to the x.
So literally the derivative of 3 to the x is just 2 to the x.
Yeah.
Okay.
But it was 3.
Now, let me point out one thing I want to make sure that you guys understand. Well, two things. For one, the rule technically is ln absolute value of x. IB is not, I still would like you to do it. IB is not as picky about writing that, even in their answers that they give. Okay, so you may see answers that don't have it. And that's not, it's kind of just an understood rule in their minds that, yes, we know x has to be positive. But the other thing is simplifying these. You know your rules for your rules for logarithms, right?
Yeah.
What could I do with this -2?
Put it as like an exponent.
Yeah, I could write that in as an exponent. So ln of x to the -2 power. Now, this is significant for a couple of reasons. First of all, if I'm squaring something, do I need absolute value anymore? No, it's going to be positive regardless. So this is ln of 1 over x squared. I don't need the absolute value anymore. And I say this because a lot of times what you'll see, especially in those problems 7, 8, or 8, 9, and 10, they'll say like, show that the integral equals this as like the first step. And they may have it looking like this when you initially do it and you get the -2 ln absolute value of x, and you're thinking, wait, how did they get there? You gotta incorporate those other rules that you've learned in the past.
So should we simplify it like that?
I don't care. Unless you have to, you can leave it as -2 ln absolute value of x. Okay? Okay, now, like I said, there is no product rule or quotient rule for integration. There's also no chain rule for integration. So when we have something like this, integral of 3x plus 2 over x squared dx, the only way that we can do that is by actually foiling it out. Okay? So we have to actually do the 3x plus 2 over x times 3x plus 2 over x. And when we FOIL that, you guys know how to FOIL.
Yeah.
So this is going to be the integral of 9x squared. 3x times 2 over x is just a plus 6. And there's 2 of those, so that's a plus 12. Plus 4 over x squared dx. Okay? Now, at this point then, we can take the integral. We couldn't with the original. So now we have the power rule. We add 1 to the exponent and divide by the new exponent. Plus 12 is a constant that's being added on here, okay? So the integral of 12 is 12x.
Oh, yeah.
Okay, 12x.
Yep.
It's just the reverse derivative.
Okay, yeah. Yeah.
So you just have to add c.
The C goes in at the end.
Now,
4 over 3x cubed, 4 over 3x. No.
alright, let's think about this one. This 4 over x squared is the same thing as what?
4 times 1 over x squared.
4 times 1 over x squared, or
4x to the negative 1.
4x to the -2, right? 4x to the -2.
So it'd have to be negative. It would be negative 4 over 2. Wait.
Hang on, do it one step at a time. It's going to be 4 times,
Okay.
what's the integral of x to the -2?
X and -1.
It's going to be x to the -1. You add 1 to the exponent and divide by the new exponent, right? I'm not simplifying anything initially here. So
Yeah.
you add 1 to the exponent, divide by the new exponent. So the integral of x to the -2 power is x to the -1 over -1. Okay? So
So it becomes
X to the -1 over x.
4, -4x to the power of -1.
yeah. So we can reduce this first part. That's a 3x cubed plus 12x and then that's going to be a minus, and I'll simplify the negative exponent, 4 over x. Yep, and then we add c, so plus c.
I really appreciate this support.
Okay? So there's a lot to remember with these, but it's not too bad if you're just careful, okay?
Now that like the rules are kind of explained, it makes a lot more sense.
Yeah.
Yeah. Once you get the hang of using the rules, it's just like
It's
derivatives,
just derivatives and then you end up adding c at the end.
okay?
Yeah.
Okay, so then this next one here, again, like we said, there's no quotient rule. So what we have to do in this case is, one of the things that we actually did when we were doing derivatives, because we didn't like using the quotient rule unless we had to, okay? So if you have a monomial in the denominator like we do here, we would split that up, so it's x squared over radical x minus 2 over radical x. And when you do that, you can either reduce or rewrite so that you have separate terms with powers of x. So I subtract the exponents on this first part. 2 minus a half is going to be 3 halves, so I have x to the 3 halves power minus, and that's 2x to the negative 1/2 power. Because it's a radical in the denominator, that's the negative 1/2 power. Okay?
Can we split them up?
And now both of these we can now use the power rule for. Alright, so the power rule, x to the 3 halves. We add 1, so it's x to the
5 halves.
5 halves. And then divided by 5 halves, which is the same as
2x over 5.
times 2/5. Yeah, so times 2/5 is the same as divided by 5 halves. And then we have minus 2, we have x to the negative 1/2. So we add 1, it's x to the
1/2.
1/2
So multiply.
divided by a half.
So it's just times 2.
So times a 2.
Plus.
Okay?
Negative 4.
So yeah, so we have 2x to the 5 halves over 5 minus 4x to the half, or you can make radical x, doesn't matter, and then plus c.
Oh,
Okay.
Mr. Hickson, you stole my part.
I don't care if you leave fractional exponents, but don't leave negative exponents. Okay, just like when we did derivatives. Alright, so
Back a little bit. What is the one part?
if you check your answers, here's some practice. The answers do leave out the ln absolute value of x, or the absolute value part. Please don't. Just get into the good habit of including it. Okay?
Sit.
So,
This is